Alright, so today we're going to do the next lesson. My job for this week was to teach about weight and balance and the importance of weight and balance. So when I kind of started thinking about weight and balance and what I wanted to teach about, I started thinking about what is the purpose of aviation? What is the purpose of flying? And that dates back to a long time ago when people started first using airplanes to transport mail. And I kind of thought it was kind of comical. I was like, I bet a couple of times they just shoved that plane full of mail, and the pilots probably had a terrible time flying the aircraft because the weight and balance was all over the place. Kind of cool, kind of thinking back there is my grandfather he actually did that. He used to fly mail for a town in Alabama. And that's what he kind of did for a while. So back then they had to understand the importance of loading the aircraft and what the packages and mail would do if they put it in this airplane, how the plane was going to perform. Because it's not going to do you any good if you put all this mail in the aircraft and the aircraft can't get off the ground or it crashes. So that's the importance of understanding weight and balance, is understanding if I load my aircraft a certain way, what are my performance characteristics and how is my aircraft going to actually handle itself. So now we're going to kind of dig into weight and balance and the importance of it. I've got a couple more examples. We'll kind of talk about some stuff I've talked about in the past. I'll bring back up just so we're all remembering some important stuff here. Most modern aircraft are designed so that if all seats, storage compartments, and fuel tanks are full, that they are actually grossly overloaded. What that means is that technically, if I have 40 seats and I can take so much X amount of fuel and Y amount of fuel, I actually can't take max everything. I can't take full fuel, full loaded, and full passengers, just because the aircraft will be overloaded, it'll be overweight, and I won't be able to operate the aircraft. Think about there's some aircraft out there that actually, when they're experiencing icing conditions, they actually have to leave a certain amount of passengers at the gate, because if they experience icing conditions, the additional weight of the potential icing could grossly overweight them, so they actually leave passengers at the gate, unfortunately. But that's kind of a extensive thought there for weight and balance. Weight and balance requires a pilot to give great consideration to the requirements of each specific flight. What that means is, how am I going to be getting from point A to point B, my fuel, my passengers, and my loading? What can I do so I can get everything from A to B in a safe and efficient manner and not have any bad gross characteristics with my aircraft? Overloading an aircraft can cause a variety of problems. You can have a longer ground roll. You can have rate and angle of climb is reduced because I'm heavier. Lower cruising range and service ceiling and maneuverability can be decreased depending on where that loading is actually taking place. I remember last couple lessons I gave this example of my dad flying the C-5 and how it was grossly overloaded with a bunch of fire trucks that he was transporting on a long haul because the flight engineers had left the fire trucks full of water. So if you think about that, when he was taking off in the C-5, it took a lot longer for him to take off the ground because he was so grossly overweight, and that overweight and that extra weight led to a longer ground roll on takeoff and landing. So that's something that kind of another big example of why it's important to make sure that our aircraft is loaded properly, and as pilots we make sure that the aircraft is loaded to standards that we are okay with and it's going to keep us comfortable. Alright, a POH or AFM includes tables or charts that give the pilot an indication of the performance expected for any weight. We can actually go in our POH or our pilot operating handbook for the Seminole and the Skyhawk, and we can actually see, okay, if I'm at this weight, what's my ground roll going to be? And I can actually take into compensation for my weight, my headwind, and all this other key factors that's going to relate to my ground roll, and actually calculate what my aircraft is going to do. And that's a performance calculation. That's something we'll talk about in other lessons, is understanding performance of the aircraft. Now we're going to talk about what weight can do if I change it and everything. So usually once you take off, your weight's not going to change too much because unless you kick a passenger out or you drop something out of the aircraft, that weight's not going to change. Where the big weight changes come in flight is from fuel burn. And that's where something we start noticing in the Seminole. Sometimes we see that little CAS message system pop up that says fuel imbalance. That's because our fuel is imbalanced and we're having different weight in different wings. So it's very important for planes that maybe don't have dual fuel flow systems from each wing at the same time to monitor how much fuel you're taking from each wing and changing it. Because I know some of the older Aero versions, I have a buddy who flies it, and every 15 minutes he has to change left and right tanks because it doesn't come from directly from both of them at the same time. So he's got to manage that weight and balance. If you also install extra radios, extra equipment such as navigation equipment, GPSs, things like that, can also add additional weight to the aircraft. And that's important that when we actually first walk into the aircraft, we go through that POH that's in the aircraft, and we ensure that the weight and balance that's in there is for the proper aircraft. That's one of the big things on the checklist that people often forget to take care of. So how does this all relate to balance and center of gravity? Well, as my weight shifts, my center of gravity shifts. So if I have a very forward center of gravity, that means my center of gravity is closer to that datum point, that datum reference point, and the seminal is that front nose gear. So as my weight and balance shifts towards that, I'm going to have a nose down tendency, meaning I'm going to have to apply extra back pressure throughout the flight to maintain a level altitude. So that means I'm going to have decreased performance on long cross countries, but the plane is more maneuverable, so there's a kind of like a change off there. Now, and vice versa, if my aircraft center of gravity moves farther aft from the datum point, then my stall characteristics are going to be bad, but I'm going to have increased performance because I'm going to have a nose up tendency, which means I'm going to have to push my nose over a little bit to keep me flying at a normal altitude, which is going to increase performance. Now, I keep throwing out the word datum. What does that mean? Datum is simply just a place that the aircraft uses to measure distance from. In the Skyhawk, it's going to be the firewall. In the Seminole, it's the front of the nose gear, that tire. Datum is just a distance from one point to another point that we can reference in terms of center of gravity and where we can locate it. Every point's got a datum point, so if I have my weight's got a datum point or a distance from that datum and things like such on, that's actually going to be directly related to the arm, the distance between the two. So that's very important when we start talking about that, and we start going through actually filling out a weight and balance sheet, which we're not going to do in this lesson because it's very hard to see it from here. But when teaching this lesson, it's very crucial that we actually have a weight and balance sheet ready for the student, and we can fill it out with all this information as we're going through it. Like I said, it's not something we're going to be able to do today for timing, and just hard to do on a video, but when we can get a student down there, we can show them, hey, this is where you fill in this is where you put your arm, this is why we need to know what our arm is. It should all click and make sense to them. Okay. So, effects of adverse balance. Operating above the maximum weight limitation compromises the structural integrity of the aircraft and can adversely affect performance. We've already talked about how having a forward and aft CG can affect my performance based on that. Also, it can actually cause structural integrity issues for the airframe. If I'm grossly overweighted and I pull more G's than I'm like normal, then that extra weight that's bearing down on my structure and my wing struts and everything can actually cause structural integrity failures, and you can actually have very big issues of stuff breaking and stuff like that. So it's very important that we don't overload baggage compartments, and the Seminole is a baggage compartment limitation. So making sure we don't put too much weight in there, because if we're cranking and banking in the aircraft, we don't want to overstress that baggage area and cause structural problems right there. And like I said, loading in a nose-heavy condition causes problems controlling and raising the nose, especially during takeoff and landing. If I have a very forward CG, if I have a lot of weight towards the front of my aircraft's not going to want to pitch up. I said it's going to have that nose-down tendency. It means I have to apply a lot more back pressure to ensure that my aircraft actually rotates off the ground smoothly. So that additional back pressure is increasing my lift, my induced drag, so I'm going to be having more drag and more lift capable, or it's going on. Lowering the nose makes the control surface very light, and actually makes it easier to overstress the aircraft. Like I said, the maneuverability of the aircraft might be greater in a nose forward CG, but it makes it easier to overstress my aircraft because it's so much easier to maneuver. So that's a big trade-off and something you understand. Unbalanced fuel can make the aircraft unstable around its lateral axis. Remember, ladder means it's going to be rolling. But it doesn't matter. Unbalanced fuel can make the aircraft unstable around its lateral axis. Sorry, I have confusion there. Stability and center of gravity limits the location of the CG are established by the manufacturer. What that means is that my loading is established by the people who designed it. So they're going to have what we call an envelope. It's going to be something in the POH, and it's going to have your weights on one side, and it's going to have your CG locations on the top and the bottom. So you can say, okay, my weight's 3,200 pounds, and my CG is 89. I'm within my envelope, I'm good to go flying. Now, anytime I go outside of that envelope, and let's say I'm outside of my CG requirements, or with the POH as I can do, and that's the point you become a test pilot. And in a training environment, in an environment where you're taking and being a professional pilot, you never want to be a test pilot. You never want to be outside of those zones of safety, if you will, the envelope we're flying. So those limits are actually built by, in the case this Piper built them, or the Skyhawks are built by the Cessnas. CG should not be located past these limits. A forward CG is often established at a location that is determined by the landing characteristics of an aircraft. A lot of words there, but what it really means is my forward CG is actually going to be determined by how much load factor and how much pressure my nose wheel can take on landing. If I have center of gravity that allows more weight in the front of my nose than my nose wheel can take, and I have my nose wheel collapse, that doesn't make sense. So it's making sure that if I have a forward CG, it's not going to be so much of a forward CG that's actually going to have my nose gear collapse or break on impact of landing. In extreme cases, a center of gravity location that is beyond the forward limit may result in nose heaviness, making it difficult or impossible to flare for landing. So when we're coming into land, we're at that low airspeed and we want to bring that nose up. It might take a lot extra back pressure, or we might even have enough available yoke usage to even get ourselves into a flare, and you'll end up just driving the nose into the ground, or you're landing on your nose gear. So having a forward center of gravity isn't very good for landing either. So that's why it's important to make sure that our center of gravity is within that envelope and it's within a good, safe level of flying. So next we're going to kind of start slowly talk about management of weight and balance and control. This is all FAR regulated. If you go Title 14 of the Code of Federal Regulations, 14 CFR, Part 23, Section 23.23, it requires establishment of ranges of weight. A lot of big words there. It's basically just giving you information of where you can go to look to check and talk about regulations and weight and balance. Alright, so one thing you should know is 14 CFR 91 does not require pilots to go and compute a weight and balance every time they go flying. Okay, so yes, it doesn't mean I shouldn't though. So think about this. If the CFR 91.9 does require the PSC to comply with the operating limits of approved AFM, I am required to comply with the weight and balance, but no, I don't have to go compute it before each flight. So why wouldn't I compute it before each flight? Because do I actually know that I'm actually flying in that envelope, in that safety realm? If I don't do it, probably not. So that's why before each flight at Liberty, we actually go and we perform a weight and balance calculation, and we make sure that we are good to go fly. Because then if we get in a problem, I can pull out this piece of paper and say, hey, look, I checked this off. I did my weight and balance. I was good. This was not the problem that we had in flight. Weight and balance is good. I've complied with CFR 91.9. That's just basically covering our entail. Advisory Circular 4313-1 is the following criteria for negligible weight changes. So if you have a weight change, you add additional weight, you need to go here, this is Advisory Circular, and make sure that this weight changing doesn't require your plane to go get weighed again or special permission or acknowledgement from the FAA. Okay, so that's going to go into weight class and how much is actually changed. Also, the FAA regulates how often your plane should get weighed. 14 CFR Part 125 requires aircraft with 20 or more seats or maximum payload capacity of 6,000 pounds or more to be weighed every 36 months, calendar months. So the FAA actually regulates how often your aircraft should get weighed, sometimes in certain examples like that. Multi-engine aircraft operated under 14 CFR Part 135 are also required to be weighed every 36 months. Some are exempt, but that's a good place to go and check to see if you actually do fall in those exemption categories. But the FAR does regulate what you need to do with weight and balance and when you need to calculate and when you need to go get your aircraft weighed. So that's important places to know and be able to understand. If the FAA asks you, hey, where would I go to find out about weight and balance, you can tell them these couple places. You can show them the FARs, you can show them the advisory circulars, and you should get thumbs up from them. So I've thrown a couple terms and I've thrown a couple definitions out there. I just want to kind of clear the air and explain what each one of these means in basic sense. An arm is the horizontal distance in inches from the reference datum line to the center of gravity of an item. So we talked about how there's a datum reference point in every aircraft. Well, what does that actually mean? Well, if we have our datum reference point, that nose gear and the seminal, we have another distance between that datum reference point and the center of gravity of, like, say, our front seats or our fuel tank, which are 95 inches from our front nose gear to our center of gravity of where our fuel tanks are. So our arm for our fuel tanks is 95 inches. So when we're going through our weight and balance sheet and we see the sections for weight, arm, and moment, in the arm section you can put 95 next to usable fuel because that's where the CG for that is. So one thing important to know is that weight times arm is going to equal moment. So I know that on the video it's going to be a little backwards for you, and I wish I could figure out why that wouldn't work. But you can see here, this is moment right here, it's an M. Here is arm and weight. So in basic math, you can actually rearrange these equations to solve for what you want to find. Very often we're going to have a weight and an arm. But in some cases when we're trying to calculate usable fuel weight, what we're actually going to have is we're going to have a weight and a moment. Because we're going to add all our weight together, we're going to add all our moments together, but what we want to know is we want to know our arm, because our arm is going to tell us where our center of gravity is for our zero takeoff weight, where our takeoff weight is, and our landing weight is. So it's going to tell us where that center of gravity is, so we want to be able to calculate that. So what you can do is you can rearrange this equation, and you can divide moment by weight, and you'll get arm. Moment divided by weight gives you arm. Arm is going to give us our center of gravity. That is how we locate where our center of gravity and where it actually falls in the envelope based on our weight. Like I said, again, I'm sorry that's backwards. I wish I could figure out a way to do it. I think it's just because of the video quality and what it is on the computer. But you can kind of see a little basic chart I kind of drew up here before the video. You have weight, arm, and moment. And this is going to be very similar to what you're going to see in our weight and balance sheets on the Skyhawk and the Seminole. Is you fill in these boxes, and what you do is when you have a blank next to zero fuel weight, you're going to add up, like, what our front seat weight is, what our baggage compartment weight is, and all like the basic empty weight of the aircraft, and you're going to get your zero fuel weight. And those all will have arms that you multiply them by to get your moment. Then you add your moments together, and you'll have a blank space in between weight and moment for arm next to your zero usable fuel weight. And what you'll do is you'll just simply divide moment by your weight, and you'll calculate your arm. And that's going to tell me where my center of gravity is for a zero fuel weight situation. Now, I was talking to Alex Fenton. I was kind of confused on why that's important. That's a phone call. That's embarrassing. And why that's important. And it's actually important for bigger aircraft who might have, stress limits on their wings and stuff. If you have a very underweight fuselage and very heavy wings, you can actually end up ripping wings off and stuff like that. So you'll see that more come into play for bigger aircraft. But for our cases, it's just good to know and good practice to start calculating it, okay? Another thing is basic empty weight is a standard empty weight plus the weight of operational equipment that have already been installed. That's something you'll see given in the planning room. It's on these red, kind of reddish pieces of paper. That's going to give you your basic empty weight, your basic arm, and your basic moment for the aircraft. And before you do this sheet, go and write those down so then you can start filling it out. Center of gravity is the point at which an aircraft would balance if it were possible to spin at that point. We talked about that before. Center of gravity is just if I took a pin and balanced my aircraft at that center of gravity, it would just balance around it. Okay? We've talked about what datum is the imaginary vertical plane or line from which all measurements of the arm are taken. And then moment is the product of weight of an item multiplied by its arm. You get your moment. So by determining the weight of the empty aircraft and adding the weight of everything loaded in the aircraft, a total weight can be determined. And from that total weight, we can actually calculate where our arm is located. And thus, we can figure out where our aircraft's center of gravity is and how the aircraft will perform based on those calculations. This is all important to do before we start jumping into performance, because if we don't understand performance, we're not going to be able to understand how the aircraft's going to perform. And it all starts with weight and balance. Understanding weight of balance then leads to me understanding performance, which leads to me understanding how my aircraft's going to fly and what I can expect when I actually get in the aircraft, okay? So that's a big thing for weight and balance. Like I said, when you're teaching a student, guys, it's very important that we take out a chart like this and we sit down and we let them fill it in and we explain why they're filling it in and what's important with it. When I sat down with Alex Fenton, we got to sit down, we got to break it down, we got to give a basic idea of, on a normal flight, this is what we're going to see, this is how we're going to calculate it. We threw a couple things in there to make the weight and balance, a little different, but it's important for our students to understand that this is what we need to do before each flight. I know I got into the issue sometimes of not always doing it before each flight because it was just so routine. But then I started thinking about, hey, what if something was different though? What if I had a passenger in the back, or what if I didn't have full fuel, or what if I had extra additional weight in there and I didn't calculate it? Technically, then I could be liable for any of the issues that happen in the aircraft because I didn't do my weight and balance. I didn't comply with the rules if they were out of them. So, as a student, it's very important that we understand why weight and balance is important, and then translating why weight and balance is important to calculating performance issues and performance data right there. So that's weight and balance. This coming week we're going to start talking about weather and weather theory. I'll be discussing weather briefings. Yeah.